All right, welcome everybody. So we have reviewed some of the basic concepts in hypothesis testing. Here's where we get to the fun part. We will explain the process by which we will be conducting hypothesis tests for essentially the remainder of the semester. Then we will have a couple special lectures. Normally I don't cover practice problems on the lectures, but I'm going to talk you through a couple of examples of that process. We'll have a couple more pieces of content, and then there'll be lots of practice questions for you to review. But make sure that you have this process down as thoroughly as possible. Again, there are very few mysteries about what sort of things are going to be on these exams. This is going to be on the exam. You're going to have to do this process. You don't have to memorize the steps. That's not something I expect you to do, but you do need to know what's done in each step and be able to do it appropriately, and also answer questions about conceptually why we do what we do in each step. But first time through, that's the worst you'll ever understand it. Just remember, if it doesn't make a lot of sense right away, hopefully we'll get there once we get those examples in our back pockets. So in hypothesis testing, I use a 5-step model to test hypotheses. If you look in the textbook, you'll see it's a 4-step model. I'm going to explain the differences in a minute. Super short version, it's all the same stuff. They just put it in a different order. That's it. Every single process is in there. There is no, they overlap by 100%. We just organize them differently, and I'll tell you why. And here's our steps first before we compare and contrast. There are 5 steps overall. The first step is define your hypotheses. Turn your research question, whatever you're looking to test, into an alternative hypothesis and a null hypothesis about the populations you're comparing. Now, important note, in the example questions and on some of the graded material, I'm going to make you identify what populations are being compared. As we see the mean of population 1, the mean of population 2, you're going to need eventually to be able to spell out what population 1 and population 2 are. But for now, the most common null hypothesis, mu1 equals mu2. Alternative, mu1 does not equal mu2. Those are the only 2 possible things that can happen when we're comparing those 2 things. Notice if we have a specific example, like in our Doritos example, we can pop it in here for mu2. Either are equally acceptable. Both are fine. By the way, what kind of test is this? Is this a non-directional or directional test? It's non-directional, which also means it would be a 2-tailed test. That region of rejection would be split among both tails. So that's step 1, list your hypotheses. You're just writing down 2 hypotheses, and you'll see the same sort of forms and patterns get repeated again and again. Then what we wind up doing is constructing a comparison distribution. So the comparison distribution is our basis of comparison for our sample mean. So here's the logic of the comparison distribution. It's the distribution of outcomes you would expect to see if the null was true. And then we place our actual result on there, and if it's really far away from the mean, we say, gosh, that's unlikely to have happened if the null was true, and we reject the null. If not, we fail to reject. For our purposes, there's 3 pieces of information that we need here in step 2. So remember when we talked about z-score, using z-scores, we said it's a combination of the mean and the standard deviation, and also that we expect it to be a normal curve. So here we provide 3 key pieces of information about that comparison distribution. First, those 2 basic descriptive statistics, the mean of either the entire population if you have it, or the sample that's used to estimate it if you don't, the standard deviation of that population. If we are dealing with a sample size larger than 1, we always convert it to a standard error. So those 2 things go together. I will tell you most of the examples in this course you're going to be converting to a standard error. It's the single most common step that people forget to do. Don't forget to do it. Remember, that was what all that sampling distribution stuff boiled down to, was just turn the standard deviation to a standard error. The formula is going to be right in front of you. You got to use it. And the last thing is you just identify the shape of the distribution. For now, that means literally just saying it's a normal curve. We're going to deal with some non-normal curves a little bit later on, but for now, you're just saying it's normal. So 3 pieces of information: the mean, standard deviation if it's a single score, but more likely the standard error if it's a sample mean, and the shape, which here is just normal curve. Step 3 is the fastest one. Remember those regions of rejection. We said there are these thresholds, and they mark the boundaries of our region of rejection. Basically, it's the minimum score you'd need to be in that region of rejection. So the size of that region of rejection and where the thresholds are, they depend on the alpha level. You will never have to identify an alpha level because it's pretty arbitrary. I'm just going to tell you a number. They also depend on whether you use a 1 or a 2-tailed test. That determines where the critical values are. There are going to be some practice items where you might have to use that normal curve table to look up what those exact critical values are. But on anything that's graded, any kind of an exam or a quiz, I'm just going to tell you the critical values or critical value. So step 3 on something graded literally boils down to just write down the number that I gave you. Figure out what the critical values are. I'm going to tell you what they are. Copy them down. But conceptually, what we're doing here is we're taking that comparison distribution. Let's do a little board work here. We're taking that comparison distribution. We are setting a region of rejection. Let's say it's two-tailed because they mostly will be. We're saying, all right, anything in there has a lower probability than alpha. It's going to let us reject the null. The threshold is what's the borderline? What's the minimum, in this case, z-score I would need to be in that region of rejection? So this is the region. I won't subject you to more of my handwriting. This is also the same thing over here. So two regions of rejection. The threshold or the critical value is what's the minimum score you'd need to be in that region of rejection. But mechanically, for our purposes, you're just copying down numbers that I'm providing for you. But what that number is telling you is what's the minimum test statistic you'll need to reject the null. Step 4, we place our sample somewhere on that comparison distribution. We calculate what's called a test statistic. Again, in these early examples, it's going to be a z-score. We use that to place our actual sample mean. Where is it? Is it above or below average? How far away is it? But ultimately, what we're doing is we're comparing that z-score to the thresholds. If the z-score, if the test statistic is beyond the threshold, or if it's equal to the threshold, we reject the null. It means its probability is less than alpha. If it falls short of the threshold, even if it's super duper duper close, we fail to reject. Calculate the test statistic. Then step 5, you compare your z-score, your test statistic from step 4, to your critical values from step 3. Again, if it's beyond the critical value or the threshold, you reject the null. If it's not, you fail to reject or retain it. That's the only two things can happen at the end in step 5. So use the phrase, you can use the phrase population 1 significantly differs from population 2. We can obviously plug in the real names of those populations. We can be specific, it's greater or smaller than, or if we fail to reject or retain it, we say it's not significantly different than population 2. So let's do a little compare and contrast, and we'll talk about some important stuff and wrap this up, move on to examples. Again, if you read the book, they have a slightly different process. Here's how those differences emerge. So here's the book step number 1, state the hypotheses, pick an alpha level. That's exactly the same as our number 1, except we never select an alpha level. That's something that's provided for you. Again, as a real researcher, you would just tend to use the standard 0.05 or 0.01. So step 1 is pretty much the same. Their step 2 is locate the critical region. This matches our step 3. I strongly prefer defining the characteristics of that comparison distribution before you figure out where the critical region is. You describe what that distribution looks like before you really start figuring out where the critical region starts, where the region of rejection is. Oh, animation's off here. The book number 3 is calculate the test statistic. That combines number 2 and number 4. It lumps those two together. Again, I like keeping them separate, and I like doing the comparison distribution stuff before we get the critical values. So their step 3 lumps our two steps together. And then book step number 4 is make a decision. That's exactly the same as our step 5. Decide whether or not you're going to reject this null hypothesis. So those 5 steps again. Identify your hypotheses. There's only going to be 2. You'll always have an alternative and a null hypothesis, and there's only a couple different forms they can possibly take, and only one form that they're really going to commonly take, especially early on. Determine the characteristics of the comparison distribution. Again, the 3 pieces of information: your measure of central tendency, your mean, your measure of variability, which is going to be the standard deviation if it's 1 score, but in the much more likely event it's a sample mean you're dealing with, it would be a standard error. And then the shape, which generally just means say it's a normal curve. Then we find the critical value or critical values. Basically, where does the region of rejection start? What's the minimum score that I need to reject the null? Then you calculate your actual score, your test statistic. Again, z-scores early on, other stuff later on. And then you compare the score from step 4 to the thresholds from step 3. If they're over the line, you reject the null. If they're not over the line, you fail to reject. pretty straightforward. So, well, it feels straightforward to me. There's not a lot of moving parts there, is what I'll tell those of you whose eyes are kind of bugging out of their head right now. So, here's how we can break down the hypothesis testing steps conceptually. Basically, when we translate this into why are we doing what we're doing, steps 1 through 3 involve setting up kind of the terms under which you're going to conduct the test. You figure out what's your alternative hypothesis. That's usually what you as a researcher predict is happening. What's the null? That's whatever possibilities are left over. What are the characteristics of that population distribution, that distribution of outcomes that you'd expect to see if the null is true, that comparison distribution? What characteristics does it have? And again, the key ones are shape, central tendency, variability. Shape, mean, standard error. How unlikely does a result need to be to reject the null? That's setting your alpha level, deciding again what sort of probability level is going to be acceptable for you. Then taking that, what's the minimum test statistic, z-score or something else, that you need to be below that probability level? This here is just finding the critical value or the threshold. What's the minimum result that you need to be in that region of rejection, to have a result that has a lower probability than alpha? And step 4, calculate your test statistic. We've already done this. We've calculated z-scores before. This is review, step 4. Step 5, compare that test stat to the minimum test stat, the threshold, from step 3. And if it's beyond the minimum or exactly on it, you reject. If it's not beyond it, you fail to reject. So those are the 5 steps. Again, I'd recommend reviewing those a couple of times. Maybe put a little cheat sheet next to you for what those steps are. Next up, we are going to jump into walking through together a couple of specific examples of applying this process to real data. I will see you there.